Given that any computer has limited RAM, how is it possible to download a 300 gigabit file from a server with 100 times less memory? Even worse, the process handling this file is often sharing that limited memory with many others. This was the kind of questions I used to ask my university professors. They just could not teach me everything, could they? They sparked this curiosity by teaching me about memory and operating system processes. I just had to satisfy it on my own. After a few years, I did. Well, kinda. Welcome to a video where we explore the bad and right ways of handling files by adding image uploading and streaming to an advanced LinkedIn clone project. As of the last video of this series, this is how our project looked like. While it's very complete, we didn't have a way to upload an image. So for creating a post, we were asking an image URL, and also the profile picture, we couldn't edit it, nor the cover picture. So that is what we'll be doing on the backend side. We are going to be learning about the bad and right ways of handling file uploading on the backend side, and in the coming video we'll be updating the front end so that it matches the UI that I showed you in the video earlier. So and if you are new to this series, it's a very complete LinkedIn clone that we are building with Java on the backend and React.js on the front end. Although you don't need to be interested in these two technologies to watch this actual video, as we'll be talking about the bad and right ways of uploading and streaming files in a general way. First thing first, if you are tasked to integrate file handling in your system, where will you even start? So if you are using a serious programming language, I mean a modern programming language, there is a chance that your programming language provide utilities for accessing, reading and deleting files. Okay, you just have to know which one to use and know what you are doing so that you don't break your system, because trust me, I'm going to show you examples in a bit. It's very easy to break your system when dealing with files. So in the Java world, we have the Java IO and also the Java NIO, which are the two packages that are provided by the Java standard library that we can use. And there is some key difference between the two, in the sense that the Java IO handle input and output using a stream, and it's a blocking mechanism, meaning when you are dealing with files using the Java IO, like when you say Java like something like read, it's going to block the main thread, so and nothing else could happen while you are reading this file. And the Java NIO is basically a non-blocking IO that has been added after the IO to solve this kind of problem. This is not really about Java IO and Java NIO. As I said, even if you're not using Java, what I will be talking about is going to be applicable. Coupled to your backend utilities, since we are actually transferring images and receiving images using the web, like the HTTP, we need to define the right content type. So there are a bunch of content type that are applicable to different scenarios. For example, we have the content type. These are, by the way, headers that are going to be within the HTTP call that we make. Like if I show you here, I'm going to say all in, and if I inspect here and look at the headers, so as you can see, we have the content type saying that I am requesting for plain text here, and we have HTML for getting HTML text. And the one that is very important when dealing with files is this multipart form data, is the way of saying to the backend, hey, I will be sending to you different type of fields, and you could also get a file as part of these different fields that I'm sending to you, and it's going to be streamed to the backend. So this is already very well done on the HTTP side. So if you are using a backend that handles HTTP, that implements all the specifications of HTTP, this problem is solved. The problem of sending files from the client to the browser in chunks if you use this multipart form data content type. But the true actually challenge lies on how we deal with this file after getting it, like on the backend side. That is what I will be talking to you about. Let's start the bad way of downloading images, so of handling the download of images on your backend. So here, this is my uploads folder where I have uploaded some images and two videos. So let's say that someone tries to want to actually download by hitting the URL with the file name being this. Okay, so this code actually works. Like what it's doing is that it is reading the file, it's grabbing the file name and reading the file as byte of an array of byte, and then it is sending it in the body. setting the content type, the header, the content type, to say if it is an image or a video. And then this header is actually used to tell the HTTP client that I am sending to you a media to be downloaded with this content disposition, and it's saying that if you can display it, and if you have to download it, the file name on the user's system should be like the same. It should be this. Okay, this is HTTP things. So the only thing that is really tied to Java here is these Spring annotations in the way of writing the response entity. But this is pure HTTP request to send a file to be downloaded. So if I show you this get file, what it is doing, it's actually just resolving this file name using the root location being the uploads, and it is so returning all the bytes that are contained within the file as an array of byte. So if we hover actually on this, Java is saying that this method is intended for simple cases where it is convenient to write all bytes into a byte array. It's not intended for reading in large files. This is actually the problem. So let me come back to the controller. So we are grabbing all the bytes. We're also grabbing the media type using this helper. So it is simply reading within the file name and return the right media type. Okay. And this actually octet stream is for saying that it's a media type for some file that I don't know. Okay, and the get file extension, all it does is just grabbing the things after the dot. Okay, so coming back to the controller, why this is problematic? So let me show you here. So if I try with this image, okay, the image has been downloaded, and if I look on my system here, as you can see, I have this this image. So we were able to read all the content of the image as byte within an array and return it. And if we look at the request here, on network request, click again, and if you look here, so if we look to the headers, these are the response headers. Okay, so it's saying that it's a stream since it's not part of one of these. It's returning this as the content type. Okay, so it's saying it's a file and I don't know which one. The content disposition, this is to say, so display the image if you can, the file is if you can. If you cannot, and that you had to download it, so use this file name. So that's what the brother did actually. If we look, we have the right file name. But let's try to grab an image that's way bigger. So I have got actually an MP4 here. It's one of my previous videos. It's a 400 gigabit file. Let me try to download this. So I'm gonna clean this, hit enter. So as you can see, I am actually getting this error. It's saying handler dispatch failed, java.lang.out of memory. And in this case, we got an error and our server didn't crash, because with the help of Spring Boot and everything that we did related to error handling in our authentication video, we are able to catch that error. So if we weren't using Spring Boot and we didn't pay attention to this situation, actually the error that is thrown is going to bubble up and crash the system, like it's going to take your production application down. So as you can see, it is just impossible to read 300 gigabit of file into an array, into a running Java process. So this is actually failing. We just cannot read that much amount of byte data and store them in an array in Java. And that will be actually the same problem for any language that you are using. So now that we know that, what is the solution? So the solution is actually, instead of reading all the files into an array, we should stream it actually. We should not read the file at once. We should read chunks of files and return them as we read them. So that's what we should be doing. So I'm going to come back here and I'm going to remove this. I'm not going to be committing this actually. I just added it to show you the problem. So I'm going to remove it. And I'm also going to be removing this, as I said, just to make a point. So just, yeah, it's running. So I'm gonna come back here and I'm gonna increment this one, and I'm gonna show you the streaming logic that we have here. So this is coming from Spring Framework, and then I need this from Java IO, the file input stream. So now what we are doing is actually, let me show you before. So before we were returning an array of byte. This is our response actually. But now, our response is a streaming response body. This is how in Spring Boot you can say this method handler is going to be returning a stream, and upon using this stream object and returning it down below, Spring Boot is actually going to do the streaming. It's going to tell the brother that I'm going to be streaming things to you, and it's going to use this Java Lambda to do the streaming, and it's going to basically run it in a separate thread. So if we hover over here, it's going to tell us a controller method return without holding up the servlet container thread. So as you can see, it's going to run in a separate thread, and it's going to use this. And what this is doing is basically using the input file stream that we are getting from java.io. So this function, what it is doing is the same as before. It's resolving the file, and then it's doing this check. And why we're doing this is actually because if a hacker gives us a file name that contains something like let's say like this, and then some file name let's say png. So if we do this resolving part, he's going to be able actually to read things outside of our uploads folder, and that we don't want. And I'm going to show you actually how he's able to do that in a bit. For now, let me just keep going. So here we're checking, we're making sure that he cannot read anything that's outside of this upload folder. And then we're returning an input file, a file input streams, and this is coming from, as I said, Java IO. So coming back to the controller, so we are doing this try with results. This is a Java feature where you are saying, I'm going to read from this input stream, and at the end of this process, you're going to close it yourself. Like if we didn't use this try with results, we're going to have to manually use a resource.close to close the input stream that we have opened, so that we don't leak memory, okay, over time. With that, if we we're gonna let the server restart. If we come back here, so this very big giant that was failing, now if I hit enter, as you can see, it actually has started downloading. So coming back to the code, our get input file so stream did that, and I kind of explained it earlier. Now I'm going to actually show you in action how an attacker might traverse our file system if we didn't have this. Okay, so let's say I have this file that is outside of my uploads folder. So it's, I'm going to call it test. So it's outside of my uploads like this. And let's say that our controller, so it was here. So let's say that our controller receives a file name. Since it's just a string, it could be something like this. Like it's just a string, so it simply could be like this, okay? And with that, although we don't have like a file called test.aviv in the upload folder, you're gonna see that we're gonna be able to access what's outside the upload folder. So I'm gonna hit sorry, I actually, so let me come back. So I meant to remove this to show you the problem. So earlier when we had this, it's stopping us, it's saying invalid file path. But now that I commented, if I hit enter, as you can see, it has downloaded, okay? So this is a problem. Like although here we are not doing this hack, like it could be like we could get from a hacker, something like this. Okay, and so having this check prevent us from this type of attacks. So we only allow people to access what's with this our upload folder, but not anything else. And while we are at it, actually, I forgot to add this check, so to make sure that the file exists before returning the input stream. So that's it for so downloading an image from the client. So what about uploading an image? So as I said, to upload an image, so basically that's the final result of the front end that we'll be building in the upcoming video. Like if I am going to select an image, I don't have any, so I'm going to go to Unsplash, and I'm going to download one. So save as, yeah, here. So I'm going to come back here and I'm going to grab it. So as you can see, we are showing actually a preview. We'll be building this UI in the next video. So I'm going to save it. So as you can see, the image has been saved, and we are getting back so this, and the client is fetching it. So when we uploaded this image, we are actually sending, if we look at the content time that we are sending, so we are sending a multi-part form data. And on the backend side, depending on the language that you are using, there should be implementations of this multi-form data. Your server should be able to read the file as it arrives on your server. It shouldn't read all the data at once. So for example, in Spring Boot, we have this multi-part so object that is actually, if we hover over, as you can see, it says a representation of an uploaded file received in a multi-part request. And it says the file contents are either stored in memory or temporarily on disk. So what happened is that if, depending on the size of the file, Spring Boot is going to handle this for us. So we are going to get a multi-part file, and if it's too large, Spring Boot is going to store it temporarily somewhere and then give us the link to this file, and we have to manage where we should be like adding it because at the end of the request, Spring Boot is going to actually clean. So it's saying the temporary storage will be cleared at the end of the request, and where we are actually getting this. So if I show you, for example, for let me come back to the authentication controller. So here is where we're updating the cover picture. So as you can see, this is the request, the endpoint that we are calling. So if we look here, it's to authentication, and then we are calling the cover picture. So here we're grabbing the authenticated user that we built in previous video, and then we are grabbing the ID of the so user that we want to update. So the ID being, in this case, this number. And then we're going to say that we are expecting a request param that is called profile picture, and it is a multi-part file. So this multi-part file, as you can see, is coming from a Spring framework, and this multi-part file, we are simply sending it down to our update profile method. Okay, and this update profile method is simply so doing some checks and then calling our save image, giving it the multi-part file. And after that, this save image is doing some checks. The first thing is that we're going to check. So this multi-part file actually has a lot of methods that we can use. One of them is this content type. So the content type is going to be something like image. something like PNG or something. Okay, if it says VG, it's going to be image SVG. Okay, so what we are doing is that we are grabbing this content type and checking whether it is an image or not using this helper, and it's simply checking if it starts with image or not, because we are expecting all images basically. And then we check the size of the file. So if it's bigger than 10 megabit, we are throwing an error here. After that, all we do is that we're gonna grab the file extension using this helper that is simply gonna return what's after the dot, and then we generate a random UID. So as you can see, all these files have these weird names, because if we try to save the file with its original name, two people could upload the same name, and it's gonna create conflicts. Okay, so we use this, and then we are simply gonna call the files.copy from the Java input IO, and we're gonna say copy the input stream that is within our multipart file to this location. So it's gonna be stored here. So if I show you, I'm actually gonna delete, and I'm gonna upload it so once more. So let me grab it, save, and as you can see, so it's here. Okay, so that is the save image that is being called by our authentication service here. So our authentication service, what it does is that if we, so let me say that I'm gonna click on this, okay, and then save. So basically what I'm doing is that I'm calling the same endpoint but sending a multipart file, like I'm sending no file. So that's what I'm doing here. So if I receive a request to my authentication here, profile picture, cover picture, it's the same actually for profile picture. So if I didn't get a file or cover picture, here I'm saying it's not required. So the client can send a request to this URL with a request param that is null. So if it is null, what we do here is that if it is null, we're going to simply call the delete file from our service. If we had a profile picture, it's the same actually for the cover picture. So I'm doing the same thing, and the delete is simply gonna call the Java method to delete it. So that is for updating the cover and the profile picture. As you can see, they are 100 here. This is for the cover, and this is for the profile picture. They are the same. And for both, we are also checking whether the authenticated user that's making this request is actually the same user that he wants to update. So with that, we protect. And I'm doing this because we actually could have admins later on, and they maybe, for example, could delete the image of someone if it's bad or something. Okay, and for them we could skip this check. Okay, this is basically why I am grabbing the ID of the user and not just relying on the authenticated user itself. If we look within the method once more, so basically what we are doing is that we are saving the image, and after the image is saved, this method is actually returning the file name. Okay, the file name that is stored here, and we are simply grabbing this file name and setting the profile picture here. And the client basically here, when he's making a request, is going to use the name. So it's going to use the name. So let me show you the images request that's being made. So it is actually simply appending the host name of the backend like this, and then using API / storage / and then we're able to stream it like I showed you earlier. So this is for the update profile picture and also for the update cover picture. But we also, if you remember, needed that for the post. So maybe I didn't show you, but like now when I am posting, I am able to grab a post and also show a preview. Actually, we're gonna be building this UI in the upcoming video if you are interested in React.js in front-end in general. So save it, and we're gonna be talking about the bad things that someone should avoid when sending images from the client side. So as you can see, it's saved here. So what I did is actually the same I am using in the feed controller that we built in previous videos. So here I have a put mapping and a post mapping. So a post mapping for creating a post, and it is the same actually. So while for updating the cover picture, we just simply sent the picture. Here we are sending the picture, but also the content of the post. So as I said, a multi-part request is actually, you can send multiple requests. So we are sending a content that's a string and a picture that's a multi-part picture, and it's not like required. And then here we do some stuff that we covered in previous videos in depth. And finally, what we are doing here is we are calling the same save image method, getting back the picture URL and setting it here. So that's basically what we are doing. And the we also have an input method that can also receive a multi-part request, and it is using the same so save method that's coming from our storage service, which is being here. And also, if you have been actually following this series from the beginning, you might be wondering how we're able actually to download the image like here, although we're not authenticated, like we're not on the UI here and authenticated. That's because actually I also went into the authentication filter here, and basically I said that for things that are mapped to API version to storage, I want you to not authenticate them. So basically we want everyone to access the images that are uploaded by users. For example, if you search for someone on Google, you might find his image on Google because the image is public. And maybe in upcoming videos we're gonna add things and to control that a little bit more, but for now we can keep it like this. And if you want to actually see all the things that have changed from the previous video, go to the repo, and it's going to be the commit number 16. So check out the commit number 16 to see what has changed from the previous videos if you want to go deeper. So yeah guys, that's it for this video. Join me in the next one where we're gonna tackle image uploading on the front end side. So what are the challenges, and how also we are able to show a preview to the user before actually uploading the actual image. So as you can see here, it didn't change because we didn't send it, and after saving you're gonna see that it's going to change here, but also here. So that's going to be our next video. So thank you so much guys for being here. Let me know if this video was helpful by commenting, by liking it, by sharing with your friends who are also maybe interested in these topics. I will see you in the next one very soon.